In the previous video I just worked, I solved for the molar mass of water, so we can go ahead and check that out. But now in this video, I'm gonna connect grams, moles, and Avogadro's number. So we're gonna kind of see how it looks, okay? So, molar mass, so it's 18.06 grams per mole. So I'm gonna erase that stuff. And so that way we have it down here. So water's molar mass is 18.016 grams per mole. So that means if I have 18.016 grams of water, so I have water right here. So if I just took some and I weighed it on a balance, okay, and I figured out how much mass it was, if it came out to 18.016 grams, then I know that I have exactly 1 mole of water. And what does that mean? That means that I have exactly 6.02 times 10 to the 23rd molecules of water. That's what that means, okay? Because these are those definitions. Now then, that is how they're all connected. I want you to see that moles connects those things. So I know if I have my molar mass, and then that's 1 mole, and 1 mole is also equal to Avogadro's number. Okay, so moles is what connects them. And so I can go from grams to moles, moles to grams, and I can go from atoms, molecules, particles, ions to moles, and then moles to atoms, particles, ions, molecules, okay? So if I want to go from grams to moles, grams is my key word. Whenever I see grams and it's asking me to do anything, I want to transition it to something else besides kilograms, milligrams, that kind of thing. If it still has the word gram in it, then that's just a normal conversion factor. But when we're doing chemistry stuff, if I see grams, then I want to go use molar mass to get to moles every single time. That is the only place that I can go from grams is to moles. And so I want to do that by using molar mass, because molar mass's units are grams per mole. So again, the water example, it's 0.06 grams per mole, or in other words, it is 18.016 grams is equal to 1 mole, okay? And so that is what connects them. And so if I know I have 87 grams of water, I'm gonna use this to figure out how many moles that is and go back and forth, okay? And we just set it up in conversion factors because our units cancel. It makes our lives a lot easier, okay? So if I see grams and moles, I'm always gonna use molar mass. If it asks me for grams, so it's saying I have moles, or I have anything else for that matter, and it wants me to go to grams, grams is still my keyword to use molar mass. I'm always gonna use molar mass when I see grams, whether I'm solving for it or I'm starting with it, it's my given. I'm gonna use molar mass to get to moles, or get from moles to grams by using molar mass. Same can be true with Avogadro's number. Okay, Avogadro's number, which is 6.02 times 10 to the 23rd, and that could be atoms, molecules, particles, or ions, okay? Any of those keywords, any of those words, and we want to go to moles, that means that you need to use Avogadro's number. So if I am given blah, blah, blah atoms of a compound, or atoms of an element, or if I'm giving blah, blah, blah molecules of a compound, or I'm giving blah, blah, blah of particles of a substance, or I'm given blah, blah, blah ions of a substance, and I want to do anything with it, no matter what it's asking me for, I first have to go to moles. And how I go to moles is by using Avogadro's number. Okay, and so we're gonna break down a couple of examples of this and just units, just slowly looking at units. Okay, so grams to moles, I need molar mass. That's what I need. Okay, moles to grams, I need molar mass. Okay, atoms to moles, I need Avogadro's number because it says atoms in it. Okay, if I go from moles to atoms, I need Avogadro's number. Why? Because it says atoms. Okay, if it says ions, I still need Avogadro's number. If it says particles, I still need Avogadro's number. If it says molecules, I still need Avogadro's number. Okay, and all of these I could flip-flop them and go from moles to those things, and I would still need Avogadro's number. Okay, so grams means molar mass, atoms, ions, particles, molecules means you need Avogadro's number. Now then, that's just doing a one-step problem, going from moles to those things or going from those things to moles. It's a one-step problem, a one-step conversion. Obviously, we can do multiple steps. Y'all learned how to do it with the other stuff. And so, if I'm going from grams, and it asks me for atoms, only thing that I can do with grams, the only thing I can ever do with grams is go straight to moles. Now from moles, thankfully, I can get to atoms, okay? But to get from grams to moles, so this part right here, I need molar mass, okay? And then to get from moles to atoms, I need Avogadro's number next. And so I'd use them in that order, okay? Same's true if they flip it on us. If we have, for instance, instead of atoms, I'm going to say molecules. Again, still means Avogadro's number. And they want grams. I can't go straight there. I will never be able to go straight there. If I have molecules, the only thing I can do is go to moles. In fact, in chemistry, like pretty much everything, you have to go to moles first, and then from moles, you can go somewhere else. So moles is always where you want to get to because moles connects everything. So we always try to go to moles first. So molecules tells me to get to moles, to get from molecules to moles, I need Avogadro's number. Okay? And then to get from moles to grams, I need molar mass. And so I want you to realize that every time you see grams, you're always going to need molar mass, and it's always going to take you 2 moles, or you're going from moles to that grams. Same thing with Avogadro's number. Every time you see atoms, molecules, particles, ions, the only thing that you can do is go 2 moles using Avogadro's number. And then the only thing that you can do if you have moles and it's asking you for those things is to use Avogadro's number to get to atoms, molecules, ions, or particles. So I want you to see how they start to connect, and then we'll actually work example problems in the next video.